Colby, 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 math.com.
There are a few challenging problems on this assignment, which is partly why there are only 5 problems. And I think this is the most challenging one, which is not always why I pick it for the help video, but in this case it was. A circle with radius of 5 centimeters intersects a circle with radius of 3 centimeters. So let's show those dimensions. I'm going to call this larger circle L for large and the smaller circle S for small. Oh, that's not what I wanted. And the larger circle has a radius of 5 centimeters, so I'll attempt to approximate the location of the center and then draw this line segment to show the radius. Why would I put a variable when I know what the dimension actually is? 5. And then for the small circle, radius of 3. Okay, so now the area of the shaded region is 7 pi over 2 square centimeters. Find the total combined area inside the circles but outside the shaded region, and leave your answer in terms of pi. So we're not going to use any 3.14 or anything here. That's just going to make the problem much more complicated and actually less precise. So we'll just leave everything in terms of pi. The area of the large circle, A sub L, is equal to pi multiplied by the radius of the large circle squared. So the area of the large circle is equal to pi multiplied by 5 squared, or 25 pi. The area of the small circle, A sub S, is equal to pi multiplied by the small radius squared, or pi multiplied by 3 squared. So the area of the small circle is 9 pi. You can pretty much tell you're going to need those areas, but then how do you use them? You really need to almost, I mean, there's many ways to think about this, but I think the best way is to define 2 regions. I'm going to outline this first region in purple. Not easy to do on the writing tablet, but I think, okay, if I define that area, the area of the large circle, not including the shaded area, as I'll just call that A. And then for the small circle, if I define, bad choice, hold on. If I define the area inside of the small circle but outside of the shaded region, this area as B. If you then start to if you create an expression for the area of B and the area of A, using the areas of each of the circles and this additional information we've been given, if you create expressions for those 2 areas, then I think you can answer this question. So why don't you try doing that during the pause and then come back and see how you did.
Paused.
The area A would be the area inside the large circle, not including the shaded region, would be the large area minus the shaded region's area, which is 7 pi over 2. So the area of region A will equal 25 pi minus 7 pi over 2. The area inside the small circle but outside the shaded region, area B, will be equal to the small area minus 7 pi over 2, or 9 pi minus 7 pi over 2. And we can start to create a common denominator here and do the computation in each of these individual expressions, but I think it's actually going to work out better if we just move towards our ultimate answer, which would be the total area inside the circles, but outside the shaded region would be the sum of area A and area B. And that equals 25 pi. 25, oh, really? 25 pi minus 7 pi over 2 plus 9 pi minus 7 pi over 2. And you know from PEMDAS we should do this, the subtraction and addition in whatever order we see as we go left to right, but you also, if you can recognize that subtracting 7 pi over 2 is the same as adding negative 7 pi over 2, you get some experience with manipulating expressions like this, and you realize you can associate. And so we can think of this as 25 pi plus 9 pi, and just realizing that we're subtracting 7 pi over 2 twice. So we're subtracting 2 times 7 pi over 2. And 2 times half of 7 pi, these 2's will factor out or cancel out, and we'll just be left with 7 pi. So we get, I'm going to scroll down a bit. I always forget I have this available to me. 25 pi and 9 pi is 34 pi minus 7 pi, which that difference would be 27 pi. I should put my units. Centimeters squared, centimeters squared. Okay, I hope that helped with the assignment. We'll see you tomorrow.